Look at our geometry chapter 7 practice test. So we'll go ahead and get started here. We've got a question about a model. It's made of a car. The car is 9 feet long. The model is 6 inches long. We want to know the ratio of the length of the model to the length of the car. You can see this is multiple choice. Notice the choices don't have any units in them, so we need to convert these units so they are the same. I would actually opt to change the 6 inches to half of a foot. I know it might seem like a weird choice. And they want the ratio of the model to the length of the car, so 1/2 to 18, or sorry, 9 is what we're looking at. And of course we don't really want a fraction in our ratio, so we would double both sides of that ratio in order to get it to 1 to 18. So 1/2 to 9, the same as 1 to 18. You could do the same thing with converting the feet to inches. 9 times 12 is 108, so it would be 6 to 108, which is the same as 1/18. Looking at number 2, we've got the measures of the angles of a triangle. They're in the extender ratio 357. We want to know the measure of the smallest angle. The way I think of those is I think of it as the ratio being like 3x plus 5x plus 7x equals 180. And so then I just add the x's together. We get 15x equals 180. And then we just divide by the 15 in order to find x, which is 12. Now notice 12 is one of the choices, so they are, again, trying to mess with you a little bit there. They want to know the measure of the smallest angle. Well, the smallest angle would correspond to the 3x, so we would really do 3 times 12, and so then that would give us 36. So we're really looking at B for that one. Alright, for number 3, we've got this proportion, x plus 3 over 3 equals y plus 2 over 2. Then x over 3 would equal what? This is actually one of those properties of proportions, which if you know that, you can just know then that this is y over 2 for that one. If you don't know that, then here's how I might go about kind of thinking of this one. I can divide the x plus 3 over 3, or sorry, divide the x plus 3 by 3. We have x over 3. That's going to be plus 3 over 3, which is just 1. And that's going to equal y over 2 plus 2 over 2, which is just 1. So if you subtract the 1 from both sides, we do minus 1 to each side there, then you just get x over 3 equals y over 2. So even if you forget that property, you can still get there to that right answer, just doing a little bit of algebra there, really. For number 4, they want to know if those polygons are similar. If they are, we need to write a similarity statement. So notice these ends here, the 2.5 and the 3, they're the same, but then the 6 and the 9, the 6.4, 9.6, those don't match up. So these are not similar polygons. So we're looking at D for that one. Moving on to page 2, we get number 5. So the polygons are similar, but not necessarily drawn to scale. They want us to find the value of x. The only place x is right here, in this side, x minus 3, so we just set up a proportion in order to find the value of x. So the x minus 3 would correspond to the 2.5, the 8 corresponds to the 2, and the 16 corresponds to the 4. So I have a couple options as far as how I would set up that proportion. For me, I'd probably just do x minus 3 over 8. I like to keep the numbers from the same shape in the same fraction. And then I would have to do 2.5 over 2. So we are kind of stuck with that 2.5 because it corresponds to the x minus 3. I could have used the 16 and the 4 rather than the 8 and the 2, but I generally will opt for the smaller number there. From here, you could do a whole cross multiplication if you wanted to. Personally, I would just multiply both sides of the equation by 8. Then the 8's on this side cancel out, and we get x minus 3 equals, and again, there's a number of different ways you can figure out what the 2.5 over 2 times 8 is, but really that just ends up being 10. We add the 3 to both sides, we get x equals 13. So we're really looking at A. And again, notice this time they want us to find the value of x. Earlier we had a similar situation, we had to find the measure of the angle. So if they actually wanted to know the length of this side, then the length of the side would be 10. And so make sure you understand what they're actually asking for in those types of questions. Moving on to number 6, we've got a scale drawing of the solar system. The scale is 1 millimeter equals 500 kilometers. For a planet with a diameter of 5,000 kilometers, what should be the diameter of the drawing of the planet? I think with these, it oftentimes helps to understand what your ratio is going to be. And we're trying to find the diameter of the drawing of the planet, so I would probably do the drawing over the actual for my kind of fraction and my proportions. So the scale they give us is 1 millimeter to 500, those are zeros, kilometers. And so that will equal what we're trying to find, x over 5,000 kilometers. And being that, how the units match up, then in the numerator, this has to be millimeters. And again, you might look at this one and say, well, I can tell the answer, and that's fine, but if the numbers don't work out quite so nice, it's nice to be able to know how to do this. Really what we'd want to do is multiply both sides of the equation by the 5,000. And you do that on the right-hand side as well as the left, so then those cancel out. You really end up with 5,000 divided by 500, and so then we get just the 10 millimeters for that one. Moving on to number 7, we want to know, are the triangles similar and how do we know? And again, we've got some different options, so 3 yeses and 1 no. Really what we want to do is see, do these triangles have the same angle? So really the only yes I would be considering would be angle, because we don't have any information about sides. And they give us the 84.6, so we know, of course, those are the same. The question is, would this triangle have a 66 here? Would this one have a 30.4 there? If they do, then yeah, they're similar. If not, then they're not similar. We do know that the sum of the angles of a triangle is 180, so we could figure out both of these kind of mystery angles, but really we just need to figure out one. So we would know that 84.6 plus 30.4 plus, I'm just going to call this mystery angle x, would have to equal 180 degrees, and we could solve that for x and see if that actually is 66. When we add the 84.6 and the 30.4 together, we get 115 plus the x equals 180. So we would subtract the 115 from both sides of that equation, and we get x to actually equal 65. So if this angle here is 65 degrees rather than 66 degrees, then no, those two triangles are not similar. Then moving on to number 8. Again, state whether the triangles are similar, so write a similarity statement and the postulate or theorem that you used. And so what we're looking at here is these do have the same angle measure. Those are 29 degrees. And so as long as these sides are in proportion, then yes, these triangles would be similar. So the 16 to 8 is going to be the same as 64 to 32. Those both equal 2. And there's a number of different ways you can set up those proportions. What we're looking at is, yes, those are the same proportion. So by side angle side, those two triangles are congruent. Not congruent, similar. Be careful. Notice the other options don't have side, angle, side. We got side, 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 which we can't use. Angle, side, angle, which we can't use. And of course they are similar. One tricky way to do this is to have side, angle, side be an option for more than one thing, and then just name the triangles incorrectly over here. So since we just have side, angle, side, I wasn't paying too much attention to this. But we should make sure that, yes, QRS corresponds to VTU. So just be careful with that.